Our next speaker is Jaan Tallinn, and he is one of the co-founders of Skype, and I have to tell you guys, that's one of my favorite programs in the entire world, which means it's the program I complain about the most. And every time, this is exactly how we end every single sentence whenever we have a problem with Skype. You know, it's not quite doing what we wanted, or we can't, they change the user interface, we have to go figure it out again. We're like, well, they only got $3 billion. It takes $6 billion to do software correctly. So for us, that's our philosophy of we need to build better software all the time. Luckily, Skype actually is improving dramatically. We live, I mean, when I say I use Skype, there's a lot of popular programs out there. I am always amazed someone isn't using Skype. First off, it's free. Secondly, it means you can make free phone calls anywhere to anyone else who has Skype. And it's free. So they should have Skype. So, yes, my whole team, 20 of us, we do our chatting and then we'll jump to a video if it's absolutely necessary, but fundamentally, this is where we keep our track and then we copy and paste stuff. Thank you for making Skype. But specifically and far more interesting to me is, having just finally met one of the creators and giving him crap about Skype, is that he, like myself, cares about the future. One of the reasons, as you know, we're doing BIL is because we care about what's going to happen next. He believes in humanity, wants to make a change. He's worried about it. I'm worried about it. There's some scary stuff out there, and he's going to address some of these points. Jaan, if you please come on up. The mic is yours.
Hello, Bill. So my talk, I have to adjust the microphone here. How do I do that? This is a shortened version of a talk that I've been giving in various universities around the world. And for BIL, I've never been to BIL before, but I suspect that for BIL it's a little bit too serious, a little bit, some might be even depressing. So I thought I'd better choose my attire very carefully this morning. So if you find the slides too serious or depressing, just firmly but gently direct the gaze to my shirt, and the life will be good again. So as the introduction says, I'm going to talk about optimization processes. An optimization process is a good concept because it captures an important aspect of seemingly very different things, such as evolution, humans, or computer programs. Optimization process is basically a process that systematically picks designs from available design, from a possible space of solutions according to some criteria that is optimizing for. Furthermore, I will describe the curse of optimization. That is, if you are a sufficiently powerful optimizer, you can disrupt yourself by designing a new optimization process that's more powerful than you are. So that's what happened to evolution when it produced humans. And that's what might happen to us later this century should we manage to produce AGI, that is artificial general intelligence. To start off, let's look at where the technological progress is heading. Not long ago, humans used to be much better at chess than computers. That changed on the 11th of May 1997 when IBM's Deep Blue beat chess champion Garry Kasparov. Although computer chess has never made big headlines since, it has continued to advance. So basically, if you are a human being, today, 15 years later, even a mobile phone can beat you at chess. And interestingly, many recent improvements in chess engines are not specific to chess. Techniques such as Monte Carlo search can improve computers' ability to play any game. The next milestone. On October 8, 2005, 5 robot cars successfully complete a 2,200-kilometer race in Mojave Desert, just as Brad Templeton described earlier. So now computers can drive cars. 2008, a company called Boston Dynamics releases video footage of their 4-legged animal robot capable of traversing difficult terrain. 2009, the US Air Force commits to a strategic plan to replace human pilots with robots within 30 years. 2009, the so-called flash crash on the 6th of May, where the Dow Jones index drops by an all-time record, only to recover in the next few minutes. The crash was caused by unintended consequences in activity of stock trading robots, and those robots now account for the majority of the trading volume on US stock market. An MIT researcher and a friend of mine, Alex Wisner-Gross, once described the current situation on stock markets as that human traders are just like plants, and robots, just carnivorous robots, just run circles around them. 2011, in February, IBM's Watson beats the best human Jeopardy players, Ken Jennings and Brad Rutter. And in October, Apple releases the first reliable voice recognition system in a mass market product. So now we live with computers that can understand what we say. Based on projections, before this decade is over, computers will be beating humans in the last traditional game that has so far resisted computer dominance, the ancient game of Go. So step by step, computers catch up to human competence and then proceed to utterly crush us in these domains. Which raises the question, what happens if computers outstrip us in all domains, including things like science, politics, programming? Are there domains that are so important that we must defend them as the last human bastions? The answer is yes. For example, let's look at what might happen if a program becomes as good in programming as the humans that created it. This is how, at least conceptually, a typical main loop of a robot looks like. A robot like a self-driving car or UAV. And to pick up the microphone here, so I could... I'm not close enough to the screen. Anyway, so what happens on this, in this program? First, the program reads input from the sensors, such as cameras. Then it builds a word model based on its observation history and any prior knowledge it had. And I'm not sure if I mentioned, this is actually like a generalized concept of what the main loop of a robot looks like. Once it has once it has a history of observations, it uses it to build a word model based on that history and any prior knowledge programmers might have input. For example, the word model of a self-driving car includes things like position, speed, shape of the road, and other nearby vehicles. Then on lines 4 and 5, the programmer has inserted a stop condition. If according to the word model, the goal has been achieved, or if an unexpected situation has occurred, the main loop terminates and returns control to operating system and eventually to humans. The last two lines here do the heavy lifting. An optimizer called pick best action picks the next action to execute towards a given goal, and the action is then sent to whatever output mechanism the robot has. Finally, the loop starts all over again. Now, can you already see what happens if the word model becomes detailed enough to include those very lines of code listed here? The pick best action subroutine then gets busy to find a workaround for the stop condition. It might try to override it, or even hack into the underlying operating system, because it can reason that after the break line here is hit, it will no longer be able to take further actions towards the goal. And it's important to realize that this is not, as a result, this like unexpected behavior is not the result of programming being, program becoming like self-conscious or self-aware or something, some other like sci-fi nonsense. It's just what the programmer asked it to do. So it's just a plain old bug. Unfortunately, I've been talking to AI developers around the world, and all AGI programs today have this bug. More generally, British statistician I.J. Good observed already in 1965, and allow me to repeat his famous quote: "Let an ultra-intelligent machine be defined as a machine that can far surpass all the intellectual activities of any man, however clever. Since the design of machines is one of those intellectual activities, an ultra-intelligent machine could design even better machines. There would then unquestionably be an intelligence explosion, and the intelligence of man would be left far behind." Thus, the first ultra-intelligent machine is the last invention that man need ever make. Therefore, technological progress is just a step in what I call intelligent stairway, a sequence of optimization processes where each one gives birth to the next. The appearance of self-replicators on our planet 4 billion years ago launched the process of evolution. The moment when evolution produced humans marked the start of a new era. Evolution was replaced by technological progress as the dominant future-shaping force on this planet. The creation of AGI, that is artificial general intelligence, marks the start of the intelligence explosion that produces what mathematician and sci-fi author Werner Vinge called powers. That is, agents, or actually more likely just one agent, that vastly surpassed the combined intelligence of all humankind. So, if we really are on the brink of the biggest change on this planet since the invention of brains, what will the future be like? Most crucially, is the intelligence explosion something we can survive? For clues, let's compare two steps on our stairway, evolution and the technological progress. What are the aspects that make them different? In my view, first such aspect is design power. Technological progress is more powerful in the sense that it can reach out and grab designs from much larger design space than evolution. On the contrast, evolution cannot plan ahead, so it has to stick to random incremental improvements and then wait until they catch on. That's why we don't see evolution producing radios, nuclear weapons, or space rockets. Or as American molecular biologist Cynthia Keenan put it, one grad student can do things in an hour that evolution cannot do in a billion years. Second, control. Keeping legacy products from previous steps around suddenly becomes a choice. For example, consider gorillas. They are on the verge of extinction, and their only hope as species is that we humans decide to keep them around, and that's a decision we're yet to make. So it really sucks to be a gorilla today. Third, the evolution of eyes took tens of millions of years, yet the design of digital cameras, which are similar in complexity, took mere decades. So we have an example of the technological progress being able to produce systems of similar complexity about 1 million times faster than evolution. Fourth, technological progress has brought about drastic changes in the environment. Our planet has gone from producing forests to producing cities. Moreover, if you look around in a city, almost everything you see, with the obvious exception of people, of course, was produced by technological progress and not evolution. So if the changes between evolution and technological progress can be extrapolated to the intelligence explosion, then these are the things we should expect. First, the production of magical-looking artifacts, just like nuclear bombs and radios, are magical from the perspective of evolution. Second, losing control over the future, just as evolution has lost control. And finally, and most importantly, massive environmental changes that could take place 1 million times faster than we expect. That is over the course of a few days or perhaps even hours. Since any rapid massive change is bound to be harmful to bystanders, the answer to our question above is that uncontrolled intelligence explosion would be the biggest ecological catastrophe this planet has seen, and by default, we humans are unlikely to survive it. For example, it seems likely that the intelligence explosion would affect the composition of atmosphere, because both evolution and technological progress did so. So how can we make sure that we would not make the same mistake that evolution made when it produced us and lost control over our planet? The structure of the AI space that I depict as a target here, it suggests two approaches to AI safety. Either make sure that we are not going to accidentally hit the bullseye, or aim for the tiny speck in the center that corresponds to so-called friendly AI, which is to say an AGI that, in addition to being more powerful than us, probably has the humanity's interests in mind as it goes through the intelligence explosion. More precisely, the idea with friendly AI is to engineer the trajectory of the intelligence explosion so that it's basically a smooth extension of the technological progress and not something really different or disruptive. This way we would hopefully avoid becoming obsolete as a result of the same mistake. Of course, engineering friendly AI is insanely hard. One reason why it's hard is captured in this wonderful photograph from National Geographic. It shows a chimpanzee community in mourning over one of their elders who has passed away. Now look at it and bear in mind that you're witnessing animal behavior. Turns out that we value things like life, family, the environment, health, food, love and games, not because we are intelligent, but because we are animals. AGI, on the other hand, is not an animal. It's a computer program, so we have painstakingly code in everything we value, and we are nowhere close to having an idea how to do that yet. The second reason why friendly AI is still out of our reach is that creating AGI is like firing a cannon. Once the intelligence explosion starts, we won't be able to intervene and course correct. So, or another way of putting it is that because AGI is not going to be, next versions of AGI is not going to be a part of technological progress anymore, therefore we shouldn't approach the technology, AGI as any other technology we do, that we first create the first version, first crude version, and then like go and refine it. We just can't do that. Therefore, we need to develop actually mathematical proofs that given program will remain committed to its original goals, even after billions of iterations of self-improvement. AI researcher Wei Dai once made the observation that if you plot AI developers on a chart of their intelligence versus how dangerous they are, you get this inverted U-shape. On the left, we have AI developers who are not dangerous because they are not capable of hitting the center of the target. On the right, we have AI developers who are capable of doing it, but who have realized that the biggest problem with AGI is not how to create it, but how to avoid the resulting ecological catastrophe. In the middle, however, we have people who are smart enough to potentially create an AGI, but lacking indeed either intelligence or motivation to consider the consequences. In my view, they are the ultimate Darwin Award nominees. That is, people who are engaged in an activity without realizing that this activity will kill them. I think it's important to reach out to those developers and make sure that they are aware of the safety issues. I know that it's possible because I used to be such a potential Darwin Award nominee myself, and have therefore seen both sides of the fence, so to speak. More generally, it is incredibly important to start a global effort involving philosophers and theoretical researchers on one hand, and down in the trenches, AI developers on the other, and together design a safety protocol for practical AI development. And I'm happy to report that just such an initiative has been launched in Oxford at the Future of Humanity Institute. And furthermore, another institute focused on this and other existential risks is being launched at the Cambridge University by philosopher Hugh Price and the famous astronomer Martin Rees and myself. Not to mention the ongoing efforts of the Singularity Institute here in the US. So to sum it up, if we view AGI as something that will replace human-driven technological progress with a computer-driven intelligence explosion, we can't escape the conclusion that it will be an ecological catastrophe by default. Second, we need to enlighten AI developers to help them out of the Darwin Award nominee zone. And finally, we need a global effort to prepare the practical safety protocol. Thank you. 5 minutes? Okay, 5 minutes for question. All right.
What can we do to help?
There is, yeah, question was like, what can we do to help? I think one thing that everybody can do is that kind of help in bringing, like, moving these topics from science fiction, where they get laughed at, to actual serious academic research. And so, because like very often when I talk to people about these issues, the main pool of ideas that they draw from is science fiction, and science fiction has been optimized for not being right, but it has been optimized for being interesting. So therefore, like whenever somebody draws a science fiction quote, I prescribe that you should finish the sentence that never happened. Therefore, Another thing, well, there's a great website called facingthesingularity.com that's written by the executive director of Singularity Institute that actually summarizes the issues and has lots of links and wealth of resources there. Mm.
What about the idea that we actually need AGI to save our butts for humanity to survive?
Yes, the question is, what about the idea that we actually need the AGI to save the humanity? Yes, one of the reasons why I'm really drawn to this topic is that the AGI is really volatile technology in the sense that if things go wrong, they go really wrong. But if things go right, they go really right, in the sense that, like, for example, if you manage to build an AGI that is smarter than technologically equipped humanity and has humanity's interests in mind, we will automatically kind of get a free pass with for other technological dangers. So that, like, building a friendly AI might be a good way to address other technological problems. So yes, but the problem is that right now we don't have a good idea how to do that. Right, have 2 minutes more. There.
So are you familiar with Kevin Klein and what technology wants?
Okay.
Views that this is inevitable? That it's not in our control?
I'm not familiar with Kevin Klein and what technology wants. No, I'm not familiar. I am familiar with similar sounding. Oops. That's from a similar sounding idea of by Stanford researcher Steve Omohundra about how it was. AI drives. What do AI want as an instrumental goal? So the idea is that whatever goals the AI has, there are a lot of things like gathering up resources and accumulating knowledge that will help it towards whatever final goals it has. So it's actually you can use that and reason about what's going to happen.
We have time for one more question, and please,
There.
in the crowd, speak up, because nobody can hear anybody really right now.
In your comments of robotic trading, do you feel that the catastrophe caused has moved them to be more dangerous or more friendly in learning?
Okay, the question is that do I think that Flash crash has made the robots more dangerous or less, or the system more dangerous or less dangerous? I don't think that there has been like significant change either way from that particular issue, but I haven't thought about it that much to actually, so perhaps there is, I don't know. Right, thank you.